rotating, the tidal bulge would point directly toward the moon. But the Earth is rotating pretty quickly. So in fact, the tidal bulge tends to be a little bit ahead of the direction toward the moon. That means the moon's gravity is pulling back on the Earth's bulge a little bit, retarding its rotation ever so slightly.
But the tidal bulge on Earth also has a reactive force on the moon.
This tidal bulge pulls the moon ahead in its orbit. It's constantly trying to tug the moon faster. But the moon doesn't want to go faster in its orbit. Instead, what happens, if you imagine throwing a slingshot and swinging it faster, it wants to go out. And that's what the moon does. It goes outward because it's being tugged faster in its orbit. So gradually over the years, the moon is moving farther and farther out.
The complex gravitational dance between the two partners is now pushing the moon away from Earth at a rate of 1.5 inches per year. Over billions of years, the moon's recession has slowed the Earth's rotation from 5-hour days to our 24-hour day today.
The whole idea of this rotation of the Earth being influenced by the moon is a little bit like what you see when a figure skater is spinning, and she pulls her arms in close and spins, she spins faster. And she throws her arms out to slow down. And this is all what the physicists would call angular momentum. But it's the same idea. As the moon moved out, it's kind of like throwing those arms out, and that slows down the rotation in the whole system.
But what if the giant impact had never happened? The changes to Earth would be even more drastic than if the moon now suddenly disappeared. Today, would we recognize an Earth that never had a moon? And would humans even exist? If the moon disappeared instantly, Earth would undergo changes like possible tsunamis, a shift in ocean currents, sea life extinctions, and eventual massive climate swings. But if the moon had never existed, Earth would be unrecognizable to anyone today.
Without the moon, life on Earth would probably look quite different. In particular, humans might well never have come into existence.
About 150 million years after a moonless Earth forms, 4.5 billion years ago, it moves out of its hot molten phase and begins cooling. The day is only about 8 hours long.
If we had an 8-hour rotation period, we'd have 4 hours of daylight, 4 hours of night. The nights would be totally black if we don't have a moon.
Once cooled, our planet is temperate enough to retain water. Heat escaping from Earth's core drives steam and carbon dioxide beyond the surface, creating a thick atmosphere.
Over a period of time, many years, all that atmosphere would have kind of collapsed back out, and then as it cooled, the oceans would have formed in torrential rainstorms.
Icy asteroids continually pummel the planet, bringing in another large source of water. With a smaller, cooler molten core, there are probably no plate tectonics, and therefore no large mountains and huge ocean basins. Water soon covers most of the planet's more uniform crust.
We certainly would have a higher sea level than we have today, less continental area, and that would be a different world. Our blue marble would be even bluer.
Ironically, even with all that water, the early moonless Earth would have smaller tides, determined only by the gravitation of the sun. They would be just 1/3 the size of our current tides. The range between